Hi, welcome back. So we're in chapter 1, introduction, prediction from the start to the end. In this chapter, we're going to be looking at number of outlines. First, we'll be looking at the PCI strategy. And basically, it starts by establishing a theoretical understanding of the subject at hand. In other words, what we're going to do in every subject, we're going to try to understand the theory behind the subject. And once we establish that theoretical understanding using any available tools, for example, I might use only language, a 3 sub-step in it. The first one, I call it the intelligence analysis. Next, you do some kind of a feature extraction. And finally, of course, you introduce what's called the predictive modeling. So I think the major importance of the Big Bang of data science in this digital book, in the first book, we have accomplished the property of those shapes. For example, department of geometry, trigeometry, fractal geometry, for example. Maybe you've got differential geometry, etc. Now, finally, once the sentence was taken place and we understood how to create a sentence in a spoken language, we needed a last system that put all together to create a comprehensive image, including the emotional, the logic, the idea, the connection, and that we are interested to investigate. Now, this leads us to the subject of length, area, and volume. For instance, in the Euclidean metric, to measure the distance between these 2 points happens for 1 dimension, because now we have a line. In 2 dimensions, then my measure would lead to the discussion of an area. The question is, what is the value of these coefficients? These alphas, what I have written here, is the entire foundation of artificial intelligence. Let me share with you one more example. You have this a prism, right? 2 and 2 and 2. Actually, 2 here is the indeterminate variable. Could have been only 1. I calculated only one side. However, if it could have been a 3, it could have been 1, depends on the design of the prism. But the point is, hi, welcome back. So we are in chapter 3, you must know, on the outline of equation, function, and system. I hope by now the idea of equations is quite clear to you and how it is important. In order to start to speak the language of mathematics, you must be able actually to translate any problem into a mathematical equation. And then from equation, you might sum number of equations into a system and then extract certain function. And that is actually the model that can help you to start. What is the alpha here? The alpha here should be the change of y over the change of x, right? Multiply, of course, by the indeterminate. And then I would like also to add the intercept in this case. The line that I have drawn just now from this equation is just tangent only with this point on the equation of x squared. Now I'm going to add one more line here to be 10 of them. Then I would watch the ratio difference of each line, and then I start to kind of root them until I reach to a constant. Now the number of rands that needed me to reach to that constant, I call it the power of that equation, of that theta. Reciprocal for the cosine function, we call it the sec function, and finally the cotangent. And you could see in this table actually that if you look over the number of degrees, starting from degree 1 all the way to degree 90, which is a right angle here, if you move here, established almost the entire fundamental understanding on the framework of unit circle chart. Lastly, we have just left with the one number that exists on the circle. We need to understand its story. So we know the 30 degree. I'm getting back to the example here. Getting this, and I want to show you you shouldn't be surprised. So this is my previous, or the essential slope, and then I just multiply by 2, I get this one. Now multiply by 2, you get this one. Multiply by 2. So the ratio between them, it's equal to that base. Now, the next thing I would like to do actually, take the difference between the current and the previous value, and we take that and see the difference between them. Of course, this is my function where the e is just between the both of them. This is my first slope line. And here we go, you have slope the second line, and so on. So you could see that the slope for any point in this line is exactly, the slope of this line is exactly equal to the value of y. The next thing I understand both perspective of derivative and integrals of a function. Let's first of all consider the idea of having two variables of x and y. I think we've learned all kind of equation that we can think. We've seen linear equation, we've seen constant to a certain indeterminate, and we say indeterminate to a constant power, like in this case, a log function. We're gonna do this actually mechanism, what I have done here, at every scenario. Let's go ahead and now draw the quadratic equation. You could say, I would like to get a tangent line to this point or to this point. And the quadratic equation, I have already written it, is 3 to the power of 2 plus 5x minus 10. So we're going to print the coordinate, define a very small step. And let's just start with this big step. So let's take the length of that u, and it's going to be twice as long. Now let's go ahead actually and see a real implementation. We get this point and this point. I could easily draw a vector from the origin to point B and a vector from the origin to point C. So I get these two vectors now, have to kind of draw this point down here, and then the new vector, which is going to be again from the origin, is going to be this point of this last side. Purpose of this actually to introduce you to a concept which we call it the cross product. The cross product will introduce you to another vector we call C vector. One thing you have to know that A cross B, it isn't equal to B cross A. So let me show you a real example of a 3 dimension. So we got this triangle from these 3 points in the space. I'm not connecting from the origin of A. If I ask you, what is the area? Now, the cross product of two vector u and this vector v, is captured or calculated 5 different ways of choosing one of these numbers. For the second one, so the repetition is allowed in 5 different ways the second number, and again in 5 different ways second number. That is 1, 2, 5. How about using the formula here? It is as if 5 to the power of 3. Okay, let's now change gears and try to come up with a new question. Ways that you can select 3 numbers. Selecting or forming a number of 3 digits from this list of 1, 2, 3, 4, and the map of prediction that would like to introduce to this course. Honestly speaking, it took me a very long time to actually create this map and try to bring every aspect or piece of information that you really have to understand in order to comprehend the idea of prediction. This map is divided into the right-hand side of the map, which is going to cover this area here, and the left-hand side of the map, which is going to cover this area here, and of course the source of the map, which is starting, not surprisingly, to be the data, and all of which is going to be at the heart of artificial intelligence framework, plus some of the tools, the most popular tools and frameworks that you can utilize them in order to execute every single detail inside this map. So actually, let's go ahead and elaborate the first part of the map from the left hand side. So we're in chapter 5, prediction by probability. In this chapter, we're going to be exploring number of outlines. First of all, we're going to be looking at introduction to probability, then univariate concept of probability, followed by bivariate concept of probability, and finally multivariate concept of probability. Let's go somewhere around here inside this intersect. But 3, for example, was only in B, whereby 1 was only in A. This is similar. It can be defined actually union of 3 or more set. It doesn't matter really. It indicates by using the upper arc like this union, where say I is equal 1 to n, another type of cardinality of G. I mean the total number. So G is actually equal 4 plus this x value, which is just we get 3 plus 3, which is equal to 10. The last thing, the function concept A is mapping the outline of univariate concept of probability to discuss the probability of a continuous value. And to emphasize the fact, to remind you with the map that we are actually following a path continuous. Whenever I give you a specific value, if x happens to be continuous, then the probability in this case, it must be 0. Now what we're going to do actually next, getting a real example, we have a random should be half multiplied by the height here by the width
If you sum all that together, is going to be, should be 1. K is going to be equal 1 over 12. Distribution is called the normal distribution or the Gaussian distribution. In any distribution so far we have discussed, especially given the variable is continuous, variable x and happens giving you the exact, okay, I am 2 standard deviation away. Well, this is the z value. And then what's the probability, 0.05 or whatsoever. The number of distributions are available there quite a lot, and you might get lost if you really dive deep into each one of them. That's why I think personally that the second part of lab discussion to discuss variable in a continuous form. They are all 80 cases, and we got no missing at all. So if you look at the age, the mean of the age was around 40, 39 years. So if I would actually start to look at this graph, I could say, well, anything from like, say, from 9 to like somewhere around 26 or so, the values in this interval, I could assume that it's normally distributed with mu and this one, for example, to somewhere like below that interval, like 32, so for example. And we know that the 32 does not actually fit perfectly in the gamma distribution, as we assume, not here. That's why anxiety. This contour represent that kind of relation giving both of them. This is, every point here is a kind of a pair of point of x and y joint PDF. So we are talking about the f of xy. If I would like to get back to the f of x, we call it the marginal. Given that I know the joint between both of them, well, take the integrals from minus infinity to infinity. Hi, welcome back. So we are in chapter 6, the last chapter in this book, Prediction from the Start to the End. In this chapter, we're going to be looking at prediction by RCC. Essentially, we're going to start with the introduction to the meaning of RCC and then moving to prediction by regression. The alpha 0 and the alpha 1, which we believe is going to be perfectly the best line among all these other lines I can possibly do. But my question is, this line, which is going to be alpha 0 plus alpha 1 multiplied by every value in the line space. Let's solve alpha 0 and alpha 1 using the matrix actually multiplication. And just by dividing, I was going to actually flip on the other side. So I am able now to manipulate this shape in a very different way. One more thing, you can actually manipulate the shifting part of the shape. For example, if I would have to change that, look careful what's going to happen of the alpha. It's going to look something like this. So again, somewhere around here is the best way to stop. Also, the other side of the equation, by adding this term again, this regularization is going to make a huge sense. But one more thing, maybe for this term, let me write again, if I'm talking about alpha point in here, it's obviously there's no line can be separable. And this is where you use like some kind of enhancement on the feature itself. They call the tricks of kernel. There are a number of kernels, and I think we have discussed that many times. If I take this x1 and x2 and transfer them to another features, for example, I can transfer x to a polynomial, same for x to a polynomial. You could use also some other kind of kernels. They call it, for example, the sigmoid kernel with step function. There are 2 points. In terms of phi 1, we take 1 point on this region. We take another point in that region. In terms of phi 2, it turns out both points have to be classified in the same region. Well, now in the z function, when I combine both outcomes, this is exactly what we got, which is I was talking about kind of a shaping box. Now we're going to take this exact perspective and establish the principle of a neural network. We have just captured the derivative of the loss function in terms of all the w's. When we do that, what we will get? We will get a new w's possible outcome. Let's take all this theoretical implementation, the math we have done, and do that in Python by creating our own neural network from scratch. Basically, I'm back on our notebook to discuss a data set which we have actually explored earlier on in previous sessions, only with one round. The other two, 33.32, it dropped down to from 33.44, it dropped down to 33, related to the concept of reinforcement learning. Let's assume that we have a certain environment, just to represent place or space, number of episodes. These, as we said, Q values are being updated. And they should be an indicator for you to choose the maximum exploit. This is the entire mechanism of reinforcement learning, which can give us an opportunity to look at the chance of learning. Let's see actually how we can implement this using Python. Now, in the following example, I have added to our notebook here is previously everything that we've learned so far on the discussion of prediction. There are two classes I have created here, a class called play, another class. Hi, welcome back. So we are in Chapter 6, Prediction by RCC, at the last unit of prediction from the start to the end. We have accomplished all what we need to actually understand concerning, call it the covariance. It can indicate the relationship between them in terms of variability. And from covariance, actually, we can literally construct a matrix. So the diagonal, it represents every value of a value. Maybe explain 5% and so on and so forth, but the sum of all of them must actually come to 100% anyway. Let's go ahead and implement this simple example on Python where step by step we can look at this. Where we have a data set here, it had just 150 instances by 4 different values. So you could see really by looking only these 2 components or these 2 variables, I could be able to actually make some interpretation from here. Now, I hope by the end of this entire material that we went through the steps of this book, Prediction from the start to the end, you have come to a comprehensive understanding on the mechanism or the framework of prediction and how to use your own ability actually to design your own algorithms utilizing the existence of some other frameworks. And I hope by the end of this, you are able now to proceed further. Hi, welcome back. So we're at the appendix of the book Prediction from the Start to the End. In this appendix, we're going to explore all the technical knowledge that you need to understand in order to master the use of Python programming language. But before we do so, I'm going to take you in a quick detour of introduction on the concept. I think one of the most important sections for you to understand, once you comprehend the idea of them, I think you will be able to write any piece of code and using the syntax from any other language. It doesn't really matter because every language has the exact, they only valid to be applied between 2 variables that from the same kind of integer. But in this case, X, it isn't an integer. We can put a colon and followed by that colon, it's just imagine it as a key. And the value of that colon is going to describe what type of input that is. So for example, it could be an integer. Let's assume, for example, it returns a string. Next, we will be looking at the data structure in Python. Let's take, say, Z list, X list, and say, I want you to extend. You see the annotation of the function is expecting you to make an iterable condition. We write a small short condition. Hi, welcome back. So we're at the outline to cover the basic introduction and the use of NumPy package. Now, basically, NumPy, which stands for Numerical Python, is an open source Python library that is used in almost every field of science from a perspective. And what is matrix refers to an array with 2 dimensions. If I would have to come here, Python list, say one more argument, and that is to return for us the index. So we get the unique value of 1, its index. So we are at the last section of this appendix, and that is to have a quick review on the use of TensorFlow. Now, basically, you have to understand TensorFlow is just free and open source. We have used Python as just an example. However, you can apply the same conceptual understanding from practical perspective and theoretical perspective to any other programming languages. So that was all from me. Thank you very much. Cheers.